In this video, we are going to look at the solution to the little problem I gave you last time. This was about the lottery. I am going to remind you what this game is all about very quickly now. So if you remember, there was a game with a lottery with 10 tickets, and 9 of the tickets had been sold to 9 different people. This is case A, okay? There is 1 ticket left. Each ticket is $1 and you can win $100. The question was, should you buy the ticket? Now there is a second case. Case B, it's the same lottery, 10 tickets, $1 each ticket, and you can win $100. However, now you know that 9 of the tickets have been sold to only 1 person and there is 1 ticket left. So what should you do? Should you buy the ticket? Is there any difference between case A and case B? If you want to see more, I hope you want to see more, like the video, subscribe to the channel. The more subscribers we have, the more viewers we have, the more we're going to grow this channel and the more I can bring you new videos more often. And there's a lot of stuff I would like to share with you guys. So first, let's calculate the expected value of this lottery. The expected value is defined as the odds of gain times the value of gain. This is also called Bernoulli's law. And in the case of this lottery, the odds of gain are 10%, 1 ticket out of 10, and the value of gain is $100. Therefore, the expected value is $10, okay? And that's actually not a bad deal, right? You pay $1, you have an expected value of $10, and you can win $100 if you win the jackpot, right? So the question now is, should you play? Should you play in case A, in case B, or in both cases, or should you not play at all? We know that the expected value is $10. And the real problem now is, what is the likelihood of winning in each case? Is it the same? So let's have a look at what people answered to this question. In case A, a majority of people answered yes, okay? Yes, it's a good deal, let's play. However, in case B, a majority of people answered no. They wouldn't want to play in case B. Very interesting because the expected value is still the same. So what is the reason why people want to play in case A but not in case B? Is there really a difference in your likelihood of winning between case A and case B? The likelihood of winning is actually the same in both cases. Why? Because your own probability of winning has not decreased in case B. It is still 10%. It doesn't matter that 1 person owns 9 tickets, because your own chances are still the same. Now, why is it that most people feel like case B is worse than case A? It is because most people misunderstand this situation, because they compare themselves to 1 person who bought 9 tickets in case B, and they feel that they are less likely to win than this 1 person, which is true. But that's not the point. The point is, you still have the same chances of winning than in the first case. It is still 10%, and this has not changed. Now let's take a second example of comparison that leads to irrational thinking. Let's imagine you're shopping for wine and you go to a shop and you see these 3 bottles on the shelf and you look at the price. They all have a different price, $5, $15, $25. Most people will not take the cheapest wine usually, and they won't take the most expensive one either. This means that most people would actually buy the $15 bottle wine. So now let's imagine that instead of 3 bottles, you now have 4 bottles on the shelf. You now have a 4th bottle, which is much more expensive than the others, okay? This is a very nice, for example, Châteauneuf du Pape, very good wine, but much more expensive. What would you do? When comparing the $15 bottle to the $55 bottle, the $15 bottle now seems to be much cheaper. It seems to be a really good deal, especially compared to the $25 bottle that we had before, right? Because we compare objects to the higher price, and therefore the value of this $15 bottle seems to be lower, even though the price is still the same, $15. It has not changed. This is an example of how we assign value to objects depending on what we compare it to. And this is a technique which is actually used by a lot of salespeople to try to sell you more expensive objects than what you really need. Because by comparing it to something much more expensive, you're more likely to buy something which is actually more. Like in this case, more people would be tempted to buy the $25 bottle when they see the $55 bottle next to it, because by comparison, it is a lot cheaper. But if you remove the $55 bottle, then the $25 bottle seems to be more expensive. So let me know in the comments below what you think, if you would like to see more of these type of logic games, reasoning, and making better decisions. Thanks a lot for watching. If you liked the video, click the like button, subscribe to the channel, and leave your comments below so that we can start a discussion on this. Thanks a lot, and I'll see you in the next video.